400 kilometers an hour. Let that sink in for a moment. That's Beijing to Shanghai in under 3 hours door to door. Imagine the impact on how people live and work. But here's the kicker. China's new CR450 train does it on the same energy as its 250 km/h predecessor. No bigger battery, no extra power demand, no hidden boosters. We're talking 60% more speed with the same energy input. How is this possible? The answer lies in a fascinating blend of nature's designs, cutting-edge tech, and a 5G brain that outthinks any human driver. It's a masterclass in efficiency, quietly redefining high-speed ground transport. Most of us assume more speed means more energy. It's basic physics, right? Aerodynamic drag squares with velocity. Double your speed, quadruple the drag. Yet, China Railway claims the CR450's energy consumption stays flat, at levels typical for 350 km/h trains. It's a paradox. Official tests on the Zhengzhou-Xi'an line show just 6.8 kW per kilometer, beating some 250 km/h trains. What's the trick? They're not breaking physics, they're outsmarting it. It's about leveraging every tiny advantage to achieve something extraordinary. Step inside the CR450's nose cone, and you're literally in a kingfisher's beak. Engineers laser scanned over 200 species, ran 60,000 simulations, and found this bird's elongated slope breaks the pressure wall so cleanly that disruptive sonic pings collapse into smooth waves. This biomimetic nose adds 2.8 meters, but cuts pressure drag by 12%. Underneath, shark skin-inspired micro-ridges trip the boundary layer, reducing skin friction by 22%. Together, these nature-inspired tweaks save 1.3 megawatts at 400 km/h, enough to power all onboard air conditioning. It's a testament to nature's efficiency lessons. Achieving such speeds without increasing energy also demands ruthless weight reduction without compromising safety. The CR450's carbon fiber panels wrap an aluminum honeycomb core, shaving 12 tons off the shell alone. Welded car-to-car bellows replace heavy diaphragms, and hollow axles save another 400 kilograms. Yet, crashworthiness remains robust. The front cab absorbs 6 megajoules in an impact, twice the EU spec, using braided basalt fibers engineered to delaminate slowly. It's a delicate balance of strength and lightness, allowing more efficient acceleration without extra fuel. This train isn't just fast, it's incredibly smart. Each of its 16 cars has its own sensor array and processor. Twin 5G antennas talk to Beidou satellites, updating position every 0.2 seconds. This data feeds an AI juggling variables in real time: wheel torque, HVAC control, and track gradients. It knows a 4% downgrade is coming 1.8 kilometers ahead, throttling back early to let gravity do the work. As it slows, regenerative braking pushes 8 megawatts back into the catenary lines, ready for the next train just 2 minutes behind. It's like a relay race with electron batons, optimizing the entire network's energy use. The CR450 borrows a trick from maglevs: distributed traction. Every axle is a motor, delivering power precisely where needed. These aren't ordinary motors, but permanent magnet synchronous motors with 97% efficiency, 4 points higher than traditional ones. Halbach array magnets, cooled by rushing air, eliminate the need for complex cryogenic plants. It's like maglev tech with training wheels, maximizing efficiency within existing rail infrastructure. Zero extra fuel isn't just a catchy phrase. Trackside substations report identical kilowatt-hours per seat kilometer compared to the CRH380 predecessor. But the CR450 has 30% more seats, resulting in a 25% per passenger energy drop. On the Beijing-Shanghai route, this saves 28,000 tons of coal annually, enough to power 60,000 homes. CO2 emissions drop by 46,000 tons, equivalent to planting 9 million trees. Tickets are projected to be 8% cheaper, thanks to increased capacity without new track. It's a win for the environment, economy, and passengers. High-speed rail isn't just catching up to aviation, it's shrinking continents. The CR450's tech stack is a scalable blueprint, applicable to urban metros and future 600 km/h maglevs. Europe's TGV successor is testing variable gauge bogies for faster cross-border travel. California's high-speed rail project has sought CRRC's nose cone designs. Japan's 2030 maglev is borrowing distributed motor logic. This paradigm shift will rewrite labor markets, housing patterns, and global carbon budgets. It's a quiet revolution with far-reaching implications. Of course, there are challenges. The CR450 needs tighter track geometry, more precise ballast, and 60% higher catenary tension. This means 30% higher maintenance costs, offset by energy savings within 5 years. Noise levels increase by 3 dB, but active rail dampers and sound barrier AI systems are being deployed. There's also the risk of airlines undercutting prices, potentially undermining climate gains. Policymakers must ensure fair carbon pricing to maintain the environmental benefits of sustainable transport. Looking ahead to 2050, China envisions 200,000 kilometers of high-speed rail, half above 350 km/h. Dedicated 600 km/h maglev spokes will connect mega-regions with the CR450 and its successors feeding into these arteries. 1-hour GDP circles will emerge. Integrated zones where 100 million people live within 60 minutes of each other. Polycentric cities will distribute specialized functions across wider regions. This strategic urbanization, coupled with smart city initiatives, aims to reduce per capita energy use by 30% while tripling national GDP. So how does the CR450 hit 400 km/h with zero extra fuel? It's a symphony of innovations. Kingfisher-inspired aerodynamics, lightweight yet strong materials, and AI-controlled distributed power. It's not just a faster train, it's a template for moving billions sustainably. The next time someone claims sustainability means slowing down, point to this bullet-shaped marvel, designed by birds and run by algorithms. The future is already here, clipping the platform at 400 flat. Next stop, tomorrow.